Hey everybody, I'm here at the Arches National Park Visitor Center, and I just noticed that they have this very ancient Geiger counter here. And why they had these is because we used to do uranium mining in the area. And I just wanted to give you a quick little lecture on how a Geiger counter works. Really, the theory behind a Geiger counter is effectively the same thing as just a capacitor, an air-filled capacitor. The difference is that one of the leads, the positive, the anode, is a very thin wire, and it's a high voltage thin wire. And why we do that is because when the electrons are created from ionization, and ionization just means that you've ionized the atom, you've ripped an electron off. When that electron's been ripped off of the atom in that air-filled chamber, that electron will be attracted to that anode, that very high voltage, positively charged wire, and as it's being attracted to it, it will accelerate, and it accelerates to the point where it causes secondary ionizations. And not only does it accelerate to the point that it creates secondary ionizations, those secondary ionizations will also accelerate. And as they continue to accelerate, eventually they'll hit some inner electrons in the atoms, the gas atoms that are there, and those inner electrons will be ionized. And then the crazy things happens with a Geiger counter. Those inner shell electrons, when they're removed from ionization, upper shell electrons will fall down into that lower level and give off a UV or an X-ray. And that's where the magic happens with a Geiger counter. That X-ray then goes off and creates a whole new avalanche. And so each avalanche is creating new avalanches of these electrons that are cascading down into that anode until the whole thing is discharged. It happens in a fraction of a microsecond, and that is the click of a Geiger counter.
Nice.